discuss upon the S parameters and its properties and all we have discussed, and the comparison of its losses with respect to S parameters, and we also understood that how these S parameters are going to play a vital role in matched network and mismatched networks as well. So all these things has been discussed before, and we'll just see now further continuation of that. The comparison we'll be seeing now, and so these things can be asked for your examinations to understand the comparison between S parameters, Z and Y matrices. So as you have studied before, the all the three things already. The S parameters, you have S11, S12, S21, and S22, which obeys the reciprocity property, and which also has the reciprocal devices. You can have the reciprocity property in place. So why we will see that how these three matrices can be compared with each other. So the comparison between matrix S, matrix Z, and matrix Y is what we are going to see today. So all of you just note down the heading: comparison between matrix S, Y, and Z matrix. So we'll see that. So the comparison between S matrix, Z, and Y matrix we'll see today. So we have already studied all the matrices and its properties independently. So we know that what each matrix is all about and how it is going to create an impact on the entire network. So this is what, so we'll see that how these things are having the unique properties and how impact. So for university question papers or internals, they used to ask to compare all the three matrices, ZX, ZY, and S matrix. So let us see that comparison between these three. The matrix S, matrix Z, and matrix Y represent the unique intrinsic property of the device, supplying all the circuit characteristics of the device at a given frequency. And we can just, if you see the matrix S, so it can be represented. We have already seen this in one of the properties, that matrix S can be represented as matrix Z minus U and Z plus U inverse. And if you say in admittance, you can write it matrix S as U is the unitary matrix, U minus Y, and U plus Y inverse. So these are the representations of matrix in Z and Y. What we can understand, this is unique. It has a unique intrinsic property and has the circuit characteristics are at a given frequency, and you have matrix S and matrix S in terms of Z, and you can also represent matrix S in terms of Y. So you can just note down these things. Then we'll move on to the what way each matrix S, Y, and Z are going to interrelate. If you see, if you take a two-port network, you know that if you see combinations of S parameters or Y parameters or Z parameters, any of the parameters you go across, you can see that all these parameters are, if you take a two-port network, it is 2 cross 2 matrix. Or you can say that you can go for 3 cross 3 matrix if it is 3-port device, and if it is 4 ports, you can go for 4 cross 4. So based on your requirement, you can modify the matrix, and you have to understand what property all about all these three things are in common. Okay, so just write these things till here, then one by one we'll discuss here. These are all theoretical concepts, and it's very easy for you to understand. So you inform the students to attend, those who have not joined yet. So further moving on, we have properties for matrix S, matrix Z, and matrix Y. So have you completed till here?
Yes, sir.
Okay. So how this properties for matrix S, matrix Z, and matrix Y is going to interrelate with each other, we'll see. So the number of these are the four properties, which is if you take the number of elements. So if you take matrix S or matrix Z or matrix Y, you know that S11, S12, S21, and S22. Or if you take Z, Z11, Z12, Z22, Z12 and Z22, as well as Y also. So the first thing is that the number of elements are equal. So that can be said for all the three. The number of elements will remain equal if it is a two-port network. If it is a three-port network, it will be 3 cross 3. So that is what you can see, number of elements remains equal. So second one is that for reciprocal device, both Z and matrix Z and matrix S satisfy the reciprocity property. And what is reciprocity property? If you take the Sij or Sji, all these things are equal. So you can say that with the help of reciprocity property, Zij can also be written as Zji, and Sij can be written as Sji. And the third one is if Z is symmetrical, matrix S is also, you can say that symmetrical. So if the matrix if it is symmetrical, then it is definite that matrix S is also symmetrical. So these are some of the points. But the number of elements are equal. You have reciprocity property. You have all studied these things in the previous class. So we are just summarizing these things in the title of comparison. So what you can see here is if Z is symmetrical, then matrix S is also symmetrical. So these are the three things what you can understand. So continuing further, so you can just note down these things. And then we have some of the advantages of matrix S over matrix Z or matrix Y. So we will see that advantages. So once you complete it, we'll go with the advantages. So if you complete till advantage, we will discuss that and then proceed further. So these are the three things what we have discussed now. The main thing is number of elements are equal, reciprocity property, and symmetrical in nature. So we will be discussing the advantages of matrix S over matrix Z and matrix Y. Have you completed?
Yes, sir.
Okay. So we will see that what is the advantages of matrix S over matrix Z or matrix Y. So matrix S has some of the properties, like you know that matrix S can be actually it depends on the uh, it does not depend on the voltage and current related to that what we are going to write for Z and Y. So you are going to have the incident and reflected parameters. So we are writing the S parameters based on incident and reflected parameters. So S matrix basically depends on A and B, as you have seen. We have not written anything with respect to voltage or current till now with respect to S, because it is you have in the first class you have studied that those things are very different to measure in terms of S parameters, the voltage and current. So we go with the incident and reflected parameters. So that's what we are going to see here. The advantages of S over matrix Z or matrix Y. So what is the advantage of S over matrix Z or Y? Is by microwave measurement techniques, the frequency, VSWR, voltage standing wave ratio, or power and phase of the micro signals can be measured. And these parameters like B by A or mode A square, mode B square, all these things can be measured for S parameters. But in the case of Z and Y, we go with voltage and current. So such direct correspondence is not possible with respect to Z and Y parameters. So that is one of the advantage. We'll see further. You complete this one, this portion. If you have completed, just let me know that. So these are all theoretical concepts to go ahead with. Is that completed?
Yes, sir.
So here, yeah, here there is no much things to understand here. It's all theory, and where we have understood that first number of elements with respect to the number of elements, we have seen the reciprocity property, and we have seen the symmetrical nature of Z parameters and symmetrical nature of S parameters. And when I go with the advantages, S is having more advantage compared to Z and Y, because we deal with the reflection and transmission coefficients, that is A and B and all. So it is easy to measure the frequency, VSWR, power, and all these components in the case of S parameter. So we will further move on. So compared to that, you can just continue and write it compared to Z and Y. Okay, Z or Y. So next one is unitary property. So you have studied the unitary property for S parameters, and the main advantage of this unitary property is in S parameters is it helps in the quick check of power balance of lossless structure. So if there is a mismatch in the power, you can understand that by having this unitary property, you can have a quick check over the S parameters, whether it is in place or not. So then if you go with Z and Y, Z or Y, so intermediate check is possible with respect to Z or Y parameters. So that is what I understand. So in case of S parameters, we can have a quick check of power balance, but that is not possible in case of Z or Y parameters. Then the third one is matrix S is defined as a set of reference planes. Uh, if the reference planes are changed, vary only in phase. So that is all you have with respect to the fourth property of S parameters, where we have discussed on the reference plane. Uh, so in S parameters, it is defined for a set of reference plane. If the reference are changed in S parameter, vary only in phase. So only change will happen in the case of phase. That is what phase shift property we have seen in S parameters. But if you take Z or Y has voltage and current functions, so as a function of complex impedance, so both magnitude and phase will keep changing. So these are some of the advantages of S over Z and Y. So as you know that in very high frequency we use devices. So this S matrix has to have some advantages over Z or Y parameters in order to sustain that. So we have all these things. So we have the unitary property coming into picture, and then we have this reference planes is, if you see in terms of S parameters, the reference plane only variation is with respect to the phase, but in the case of Z or Y as a function of complex, both magnitude and phase will change in the case of Z and Y parameters. You can complete it. Then we will discuss upon one problem. This problem is very important, and it is a much repeated question for internals and university question paper. So you have to definitely study this problem. So if you have, I will start discussing the problem. So have you completed that, or still you are writing? See, you can complete your notes in the class itself. See, everything is to be studied. So if you have completed, just let me know that. It's over?
Yeah, sir.
Okay. So we will now discuss upon this problem. It's not like a problem, but it's somewhat like a derivation itself. But this is very important, and in most of the question papers, you can see that this problem has been repeatedly asked, and it is very important. So all of you should mark this problem as very important and write down these things. So the problem states that the true transmission line of characteristic impedance Z1 and Z2 are joined at plane PP dash, express S parameters in terms of impedance. So what you have to do is you are going to find out S11, S22, so S11, S12, S21, and S22. So you can understand that uh, it is having two ports. So so you will have a 2 cross 2 matrix. So S11, S12, S21, and S22. So you have to find out, and you know that since the S parameters obey the reciprocity property, and you have Si j is equal to Sji and all those things, so it becomes easy for you to find out these things and simplify it further. So first you write down this problem and mark it as very important, and don't miss solving this problem for internals or externals. Most of the external question papers, we have seen this problem being repeated. Sometimes they may just vary this, instead of Z1 and Z2, they may write Z0 and ZL and all those things. So that slight variation may come, that's it. So they may write Z1, Z2, ZL, Z0, anything. So based on that, your notations will change. Other than that, solution of the problem remains the same. So all of you write this problem. We will then start solving it. So once you complete writing it, just let me know that we'll start the problem. Complete the question, and we will start with that, how to solve the problem. So what you are going to have here is you are going to have the S matrix representation in terms of Z. So that is what you are going to see here. So all of you have you have written the question. So let us proceed. Have you written the question?
Yeah, sir.
Okay. So here what you can see here is two transmission line of characteristic impedance Z1 and Z2 is given. So it can be Z1 and Z2, or it can be Z0 and ZL, anything. It can be in the question, but the procedure of solving this remains the same. So when you are using it as per the question, you can slightly modify it. So are joined at plane PP dash express S parameters in terms of impedance. So what they are saying, S parameters is S11, S12, S22 and S12 and S22. And you have to convert this into impedance. So you have to convert this into Z1 and Z2. So we are going to see how we can solve this problem. So as we have already studied this some of the equations before, we are going to use those equations in order to solve this. We have the equation for S matrix can be written as B is equal to matrix S into matrix A. So this is the same equation what we have studied before. The matrix S into matrix A will give you matrix B. So what we are going to see here is assuming that the what we should assume here is the output line to be matched, that A2 is equal to 0. So this also we have done in before that losses and all what you have studied in this. If you go back, you have taken A2 is equal to 0. So you get the reflection coefficient. First parameter, the reflection coefficient, and that is denoted as S11. I will go back for you and just show where it is there. So here we have studied all these things. Yeah, here you have studied all these things, S11, S12, S11, S22, S12 and S21. So we have seen that the reflection coefficient. So we are going to go with the reflection coefficient. So you also studied that gamma can be written as ZL minus Z0 divided by ZL plus Z0. So that is what you're going to use here, and in order to simplify it. So what you can see here is S11 is written as Z2 minus, before we have studied that ZL minus Z0 divided by ZL plus Z0. So here the notations they have given as Z1 and Z2. So since they have given Z1 and Z2, we have to write S11 as Z2 minus Z1 divided by Z2 plus Z1. So that is what we are going to see. So we will get S11 as Z2 minus Z1 divided by Z2 plus Z1. So once you get S11, that is called as the reflection coefficient. So one of the parameter of S you got in terms of Z, that is Z2 minus Z1 by Z2 plus Z1. So let us go further for the simplification. For symmetry, we have to assuming that in this match you have to take A1 is equal to 0. So that is what you have to take A1 is equal to 0. So for symmetry you will get S22. So S22 will be equal to Z1 minus Z2 divided by Z1 plus Z2, and that will be equal to minus of S11. So taking the symmetry, you'll get this one. So you got reflection coefficient as well as by using the symmetry, you get S22 as by taking A1 is equal to 0, and here you have taken A2 is equal to 0. So A2 is equal to 0, you'll get S11, and A1 is equal to 0, you will get S22. So by using the general equation, that is B is equal to S into A. So we have to just write it in terms of the general equation. So we have written that as B1 and B2. So both the equations you have already studied the same before. So you have studied these equations for B1 and B2. B1 can be represented as S11A1 plus S12A2, and B2 can be represented as S21A1 plus S22A2. So by using these two equations, now we need to further simplify. You complete it till here, then we will continue. So we got two parameters S11 and S22. Now we need to get another two parameters S12 and S21. So we'll see how to find out S12 and S21. So with output line matched, with taking the output line matched, you can take A2 is equal to 0. So you can proceed according to that. If you have completed till here, we'll move on further.
Completed, sir.
Okay. Then we will continue that. Let us take the two equations that is for B1 and B2. So B1 and B2 is S11A1 plus S12A2 and B2 is S21A1 plus S22A2. So with output line matched, when we are saying that the output line is matched, then we have to take that A2 is equal to 0. This we have done previously as well. So we have taken A2 as 0. So let us see that how the equations will be here. I am going to put A2 is equal to 0. Here, this A2 is equal to 0. I am going to put here as A2 is equal to 0. So what I'll get both the places, I'll put A2 is equal to 0. So I'll get B1 is equal to S11A1 and B2 is equal to S21A1. And when I simplify it further, I can take it as B2 is equal to A1 plus A2. Or you can see this, you can take this equation even from the figure what you have studied before. I can show you that. So here you can see that B2 can be taken as combination of A1 and B1. So from this as well you can write it. So what you will get here is B2 is equal to A1 plus B1. And what is B1? B1 from this equation 1, taking A2 is equal to 0. So what you will get, V1 is equal to S11 A1. So since this parameter is 0, so we have taken A2 is equal to 0, the entire parameter becomes 0. So this becomes 0 and there will be no parameter here. So it will be B1 is equal to S11 A1. So we are going to substitute this in this equation in place of B1. So what you're going to get, you're going to get A1 plus S11 A1 and you have taken A1 common outside. So you'll get 1 plus S11. So further, when you simplify it, you can just write this as well. B2 by A1 is equal to 1 plus S11. So whether you have completed S11 already, yeah, you have the equation for S11 here. So if I bring this equation here and substitute in place of S11, so I can simplify it further. So we will see those things. What is this B2 by A1? B2 by A1. Go back to the previous class. B2 by A1. What is that B2 by A1? You can go back to this portion. What is B2 by A1? See B2 by A1, you can see here B2 by A1 is S1, S21. So I'm going to use that there. I'm going to use that there. So instead of B2 by A1, I have used instead of B2 by A1, I have used this one. This B2 by A1 I have replaced by S21. from the previously, and 1 plus S11 as I have told you before, I have substituted. So I have substituted and simplified this. I got S21 is equal to, this is what I'll get. I will get S21 is equal to 2 Z2 divided by Z2 plus Z1. All of you got that? All of you got that? Any doubt is there regarding this? All of you got
No,
S21?
No, sir.
Okay. All of you got it? Yeah, you are clear till here?
Yes, sir.
Okay. So you got S21 and then we will continue further. Now what is left out is done with you got S11, you got S22 and you got S21. You are left out with S12. So you have to do this portion. So S12 is what we are going to do further. So to do S12, so what we have to do here, we have to take A1 is equal to 0. So with input line matched, we have to take A1 is equal to 0. So we'll get here the equation as B1 is equal to A2 plus B2. And in the same way, you have to just go ahead with this. So what is B2 from this equation? From this equation, taking substituting this portion as 0. So let us put A1 is equal to 0 and we'll be left out B2 is equal to S1, S22 and A2. So you'll be getting S2 to A2. So that S2 to A2 you have to substitute there. So let us substitute here, bring this equation and substitute at this point in B2. So you'll get A2 minus A2 plus S2 to A2, and you bring A2 outside, you will get 1 plus S2. You got all these things. Then you can finally write B1 by A2 is equal to 1 plus S22. So all of you got B1 by A2 is equal to 1 plus S22. So all of you got that? All of you got B1 by A2 is equal to 1 plus S22.
Yes, sir.
So respond to me.
Yes, sir.
Yeah. So once you got B1 by A2 is equal to 1 plus S22, let me know that what is B1 by A2. As I have already discussed with you, B2 by A1 is S21. What is B1 by A2? This one. If you are not remembering, just go back to your notes and you see what is B1 by A2. What is that? What is B1 by A2? See here, go back here. What is B1 by A2? See what is B1 by A2. You can see that it is S12. So instead of B1 by A2, you need to substitute S12. So simplify it further. S12 is equal to 1 plus S22. So substitute for S22. Substitute for S22 and you will get 1 plus Z1 minus Z2 divided by Z1 plus Z2, that is 2 Z1 by Z1 plus Z2. So finally you write this complete matrix for S, which has S11 S12, S21 and S22. Then this problem will be complete. So all of you have done till here. So all of you got S11, S12, S21 and S22. Yeah, all of you got it. S11, S12 and S11, S12, S21 and S22. You have completed. Then if you have completed, put it in matrix form and write the final answer for S matrix. So what we were required to do, we had to convert the S matrix in terms of Z matrix. So we have brought S matrix in terms of impedance. You have completed it. See, any doubt is there in this problem? Are you clear with all these things?
No, sir.
No, sir.
Any doubt is there? It's
No,
clear.
No, sir.
Okay. What about others? Any doubt? Bhumika, is that clear for you?
Yes, sir.
Okay. What about others? So it's very important. So you have to study this. It will be required. It will be the same question which comes for the examinations. So you have to prepare that well for your external examinations as well. So it's very pretty easy for 7 to 8 marks problem. It is. It's not like a problem. It is. It's very much easy to write it out. So let us continue it further and we will move on with the relations of Z, Y and ABCD parameters with S parameters. So these things you have studied in your third semester. So we are going to just rewind it once again and see that how this relationships of Z, Y and ABCD are with respect to S parameters. So whatever the Z, Y and ABCD parameters are there, we have studied in third semester. We are going to just relate it with S parameters. So you can just write down this equation for Z parameters. First class, we have written the equations for Z and ABCD parameters. Mark it as equation 1 and equation 2. So from equation 1, you can rewrite this equation in this form. V1 is equal to Z11 I1 plus Z12 I2 and V2 is equal to Z21 I1 plus Z22 I2. As well as equation 2 also can be rewritten in terms of V1 is equal to A V2 minus B I2 and I1 is equal to C V2 minus D I2. This is the same thing what you studied in third semester in network theory. So, so the same. Network analysis you have studied with respect to Z, Y, ABCD parameters. Now we are just interrelating and we will see that what is the relation with S parameters as well. So you can write those equations. So it is clear for you. Now how to solve these equations we will see. So we are going to write it and see that how it can be. You have completed this. Just I have written the equations of Z parameters
Yes.
and equations for ABCD parameter. Okay. So we will see that how the relationships can be built. Yeah. So these things you know already. So from equations for V to this equation, from this equation we are going to see. So this equation we can write I1 is equal to, just rearrange this equation, you can write it as I1 is equal to I1 is equal to 1 by Z21 V2 minus Z22 by Z21 I2. So you will end up with this by replacing this equation number, this equation. If you can put it as 1, 2, 3, 4, then you can say that replacing equation 2, that is for V2. So you can rewrite this equation as I1 is equal to 1 by Z21 V2 minus Z22 by Z21 I2. Now what we will see is we will compare the equation. This is also in I1 and this equation is also in I1. So we are going to compare these two equations. So we will see to compare these two equations. So when you compare these two equations, you can see that both are in I1, it is in V2 and this is in I2. So you will get that C can be written as 1 by Z21 and D can be written as Z22 can be written as Z22 divided by Z21. So it's pretty easy. So we have completed that. And then if you move on substituting I1, so if you substitute I1 in E, so what you have to do is you need I1 in this portion. So you substitute the equation for I1 here and see that, or you can say that substituting equation number 4, you can just put it like this. So this is my equation 1, this is my equation 2, 3 and 4, and this I can put it as 5. So I am going to substitute this here. So let me proceed in that direction. What you are going to get? So you'll get V1 is equal to, so you'll get V1 is equal to this equation. So substituting for I1 in equation of V1, we will get V1 is equal to this. After that, just simplify it further. And when you simplify it further, you will get V1 is equal to Z11 by Z21 V2 and this. So we need to compare this equation with equation number 3. So both are V1 V1 and V2 V2 and I2 I2. So you'll get A and B. So write down A and B. So all of you got A and B. Is that clear for you? So you got A, B and C and D in terms of Z. All of you got that? Yes. All of you have completed till there?
Yes, sir.
Yes, sir.
So it is clear you got A, B, C and D, correct? So we have to do this similarly for Y parameters also. You will get I1 is equal to Y11 V1 plus Y12 V2 and I2 is equal to Y21 V1 and Y22 V2. So we will do it in the next class. So today we will wind up for this here and we'll continue further in the next class. Okay, everything is clear for you?
Yes, sir.
Okay.